Good morning, everyone. Good morning. Good morning. What a great crowd. Hey, Jim. It's good to see everyone. I'm Althea Brooks, and I'm Director of Lifetime Learning in the Office of Engagement, and it's a pleasure to welcome you here. We partner with the Alumni Association in offering you more than a score each year. And so we're really delighted that you've chosen to be with us on a Saturday morning, a beautiful Saturday morning. So thanks for being here. We have a fantastic faculty member that's going to be speaking with us this morning. I'll introduce him in just a second, but I want to embarrass him just a little bit. He is one of my most favorite faculty members. Steve has a great sense of humor. He's witty, funny, but he's a fantastic teacher, so I hope you learned something today from him. He really is great, and he's going to enlighten us and engage us a bit. Before we begin, if you'll go ahead and silence the ringer on your phone. We've also passed out those beautiful orange feedback cards. We pass those out because we really love your comments. We use those to plan future programs. And so take a moment at the end and give us your feedback. We also have a drawing today, so hopefully you put your name in for the drawing. We'll be giving away the new University of Virginia book. It's called Mr. Jefferson's Telescope. It's based on 100 objects that's telling the history of the University of Virginia. If you have a moment this weekend or in the near future, stop by Small Collections Library, the Albert and Shirley Small Collections Library, and check out that exhibit. It really is fantastic. They've done a great job of putting that together. We'll also have a one-day UVA program based on the 100 objects in December. I believe the date is December 5th, but you'll hear more about that coming soon. Okay, so I'm going to take a moment and introduce Mr. Stephen Macko, our speaker for the morning, and tell you just a little bit about him. Stephen Macko is professor of isotope and organic geochemistry in the Department of Environmental Sciences here at the University of Virginia. He received his PhD from the University of Texas in chemistry. He has authored over 300 research papers and speaks all over the world at conferences, colleges, and universities. Mr. Macko, this is how I sum him up in 3 words. Scientist, well, maybe more than 3 words. Scientist, here doctor, and a stellar faculty. Here's why. Scientist. Mr. Macko was a principal research scientist on a high Arctic Canadian ice island during 5 field seasons. He has long been involved with oil spill assessment, including the Ixtoc, which was the blowout in 1979, which was the largest accidental oil spill prior to the Gulf of Mexico incident in 2010. Here, doctor. Yes, Mr. Macko is fondly known as a here doctor. I think he'll tell you a little bit more about that in a bit. But he uses here to analyze the diet and lifestyle of an individual. He has had the privilege of analyzing George Washington's hair, Edgar Allan Poe's hair, and many others. And he uses this extensive research. He has a fantastic lab that has been featured in the Discovery and the National Geographic television channel, on the National Geographic television channel, and an independent Peabody Award-winning film, The Kinghorn, which is has been shown internationally in Korea, Iceland, and Japan. Mr. Macko is a stellar faculty, and here's why. He has won numerous awards. Just a few I'll name. The All-University Teaching Award here at the University of Virginia, the Above and Beyond Speaker Award for the Office of Engagement, and he was the finalist for the State of Virginia Faculty of the Year Award. Stellar faculty, I think you'll agree. Please help me welcome Mr. Stephen Macko, our faculty speaker for today.
Thank you, Rachel. Well, thank you all for coming this morning. I know this is what makes UVA alums unique, that you can go not only to a football game, to go listen to a faculty member in the morning before the football game. So thank you again for coming. I'm here to talk with you a little bit about the chemistry of oil. And I have a daughter who knows that I'm a chemist, and so she bought me this tie, and I don't think you can see it from the back, but she allows me to wear it periodically for events like this. And so that's what I would like to talk about. Nothing unites us more than the use of energy. Energy is involved with just about everything we do, whether it's medicine, we travel, and where it's our lights. And when you think about it, it really is this thread of commonality. Our food, there's a common thread in energy. And right now, the events in Florida really bring home the fact and how dependent we are on energy, or in Houston. And so I'd like to talk with you a little bit about that. And the aspect of energy for the United States at the present time is that we are highly dependent on oil and other materials, coal, like 2/3 of our energy requirements, and then 1/3 roughly are coal and oil. There's a little bit, we're very low, maybe 10% we get from renewables, something like that, but it's rising. And so that's what I'd like to talk with you about. And this is black gold, and so just there. So I'm going to talk with you a little bit about oil and its origins and why we think we know what we know. I'll talk with you a little bit about where we get it from, and that's going to be a little bit of geology, nothing very high level. And then I'm going to talk with you about the future and where we're going and how much oil there is, and, oh yes, and protecting the environment while we do that. So that's kind of the outline. So what is crude oil, okay? And where did it come from? And some of you have some suspicions or know about this already, but it's a chemical and has these hydrocarbons in it, and those compounds are carbon and hydrogen and long chain, and that's what we burn in our cars. And that's a backbone. But there is a real fundamental argument that had gone on for years, and this is literally within up to about the last decade, about whether it had anything to do with life on Earth, or was it formed abiotically because there are hydrocarbons that we see in planets. And this argument went on for some time, and we discovered that we can use fossils to help us understand that origin of oil. And you're familiar with fossils. You've been up to the Smithsonian, I'm sure. And we have macrofossils that we use to identify creatures. Okay, we use skeletons of those, and we can identify what the creatures are. Well, similarly, in chemistry, we use skeletons, and I put up some skeletons of molecules that we have used to identify where oil came from. For example, these are 3 examples, and you may not realize that when you drive your car, you're having it distillate from compounds like this that were in crude oil. For example, there is chlorophyll, a molecule that looks just like chlorophyll that's found in all plants in the crude oil that comes out of the ground. There are molecules that are pigments. This one is one that's called carotene, and you don't find carrots in oil, but you find a pigment related to the plants that were the origin of that oil. And you may not realize it also that in every oil there are compounds that look like cholesterol. Seriously, there are compounds that look like cholesterol. We call all of these molecules biomarkers because they reflect on the biological origin of the oil. And so it's very clear that oil is of biological origin. And in fact, the previous person, I met Tommy Gold at a meeting, and I said, you know, he was challenging the origin of oil being biological. And I said, you know, I really like the idea because he is reflecting on science always being able to question what we believe and why we believe it. And that's what science is all about. All right, so it's biological. And some of you may have heard or thought that dinosaurs had something to do with the origins of oil. And I just told you it's biological. And in fact, this probably originated in 1964 at the World's Fair when Sinclair came out and they had this Brontosaurus and Apatosaurus now as their symbol. And so people started thinking about, well, dinosaurs were the origin of oil. Well, to let you know, the biological components, the skeletons that we look at, have nothing to do with dinosaurs. And in fact, so that's not, in fact, in Baltimore, there is a restaurant called the Dinosaur Barbecue. It has nothing to do with dinosaurs either. But they have good barbecue. Where oil actually comes from is related to plants, microscopic plants that literally thousands of them will fit on the head of a pin. And those are called phytoplankton. And these are some examples of phytoplankton. And you probably realize this, that they're what phytoplankton are if I told you about dinoflagellates, and that's a type of phytoplankton, but they grow in great abundances. Those abundances, oceanographers call that blooms. And the blooms that you may be aware of for phytoplankton is if you've ever heard of red tide. Any red tides? Okay? Red tides are great blooms of phytoplankton, except the sidelight for red tides is they produce a toxic material that will kill you. And so that's where you have to be careful about. Well, when these blooms happen, and they are in areas that don't have a lot of oxygen, they start falling down through, and they form sediments, they form eventually rocks. And we call those black shales, or as an organic geochemist, we might call it a source rock for the oil, because they're very rich in organic matter. Well, the Earth has had great blooms of phytoplankton in areas that were shallow seas back 150 million years ago when North America and Africa and South America were fairly close, and these great blooms of phytoplankton happened, and they were preserved as black shales. The conditions for formation were just right. I tell my students in some of my classes that I said, it's like Goldilocks and the Three Bears, okay? They were just right. So, and these shallow seas formed these deposits that were preserved from the phytoplankton blooms in those areas. And there's this magic window of about 150 million years ago that a lot of it happened. So when you drive your car on a tar road, that tar came from oil, that asphalt, that was formed in a shallow sea 150 million years ago. When you think about that. So we cook the oil under conditions that were just right. We cook the organic matter, and we form oil. So it's first changed. It forms a material called kerogen. And then at a higher temperature, about the boiling point of water, it starts to form oil. Geochemists will call that the oil window. And if you cook it too much, it actually turns into gas. And so you don't want to cook it, and the conditions have to be just right. And so this oil forms, it squeezes itself out of the black shales, and then it has to migrate. And migrates rocks that have lots of holes. We call that porosity. So where there's water inside of rocks, eventually the oil squeezes in, and that becomes where we drill for oil. Those are the reservoir rocks. And that's where we tap into, whether it's Oklahoma or in the offshore. And so this is the system that we go to. And so the oil accumulates. Oil is floating on the surface. And when it floats on the surface, it forms these peaks. And you bring along seismic, and they put sound waves down into the surface, and they find the locations. And so that where the yellow line goes through is a great location for finding future oil. And then we set up the pumping system. And there is, in addition to just simply pumping, because if you pump it out, there's incredible technology that the engineers have figured out. If you pump too fast, you lose it, and you can pump it at just the right pace, and you can get the maximum amount of yield. Well, recently, we have this oil abundance that's been increasing in this country because of what we call enhanced technologies. And so by injecting steam or chemicals into those environments, we actually enhance the recovery for oil and abandoned oil wells because we can heat it up and we can put the chemicals to help the transport of the oil out of those reservoirs. And so that's where enhanced recovery is coming from. So how long have we used oil? And it's a kind of a good question because I mean, if you are familiar with biblical stories, there is oil in a lot of the stories. Moses and the bulrushes, the bulrushes floated because of oil, tar, and the asphalt. The Tower of Babel had oil mentioned, and it's asphalt, and that held the bricks together. And so these are things, these are stories that go back thousands of years. But actually, there are artifacts that go back much further than that, where oil was used to hold arrowheads onto shafts, or knives onto shafts. They go back 10 to 20,000 years, or where oil and artifacts like that were used. And I'm going to tell you a story where I've been involved with the use of, discovery of tar and oil that was found in Israel. It's found on what are broken pieces of pottery. They're called potsherds. Pottery was commonly used for storing water or olive oil and shipping it, and if you coated it with tar, it would prevent the oil from leaking out. Can prevent the water from leaking out or the olive oil from leaking out. So we had a site in Israel that we went to. It's called Tel Mikneh, and it's the city was Ekron, and the Philistines lived there. And there was a period of this Philistine period of occupation was like 1,200 years. BCE means before Common Era, so it's like BC. And for about 500 years, there was trade in oil between these deposits of asphalts and the city of Ekron. And those, where did that oil come from? And it came from a couple of locations across, and there is a pointer. It came from a couple of locations here at the Dead Sea. And so by using those molecular skeletons, we could identify what was the source of these tars. And some of these tar, they weighed tons. And so they were a great location for the precious material that we called oil. But it was tar. And they transported it from over here to the Philistines over here. And that's where these pots were made. And the interesting side of this is that this was going on for about 500 years. So was there a story about where these oils were coming from, these blocks here and there? And during the time, if you're familiar inside the Bible, there's a great record of Samson and Delilah. There was David and Goliath. And in those stories, there were great wars going on between Israel and the Philistines. Well, the curious part was that the tars had to be transported across enemy territory in order to get to the Philistine town of Ekron. And so we identified that it was clearly happening here. And during the peace times, when the Syrian peace period was on, that was fine. That was kind of like 200 years before Christian era, 400 years. But at 1,000 years, how was it getting there? And there was clearly that there was transport of this tar, this precious material that was being used for everything, across enemy territory, suggesting that profitable commerce surpassed religious, political, and ethnic conflicts as we commonly see today. Profitable commerce. So how much oil is there? How do we measure it? You know, what do we use oil for? And what about other aspects of renewable energy? Well, I have to identify first, because when you hear about an oil spill, you probably hear that it's in barrels of oil. And barrels doesn't mean a lot. And over the years, we've used barrels in order to pack away liquids and grains. And the size of barrels changed tremendously. For example, here is a barrel that was filled with whale oil. And you can see that's not your common barrel when you think of a 55-gallon drum. And we had whale oil was commonly, stored in barrels that a person would make on board the ship. And there was 30 to 35 gallons of oil, and you might get, 30 to 40 barrels of oil from a single whale. And so one of the things that you might have heard is that the reason that oil came into existence as a major economic part of the United States was because it was replacing whale oil. And that's what was causing the whales to decline. It's myth. Okay, if you go through and do the calculation that we were harvesting a few thousand whales, and a whale was having maybe 30 to 40 barrels at the time, that gives you, a few million gallons of oil, and a population of the world which was on the order of a billion. And that really means, I've done the calculation, that means that everybody on the planet would get about that much whale oil. And so it just isn't. And so there were other options for creating energy that wasn't only whale oil. But whale oil was an economic driver, $2 a gallon. Sounds like gasoline, doesn't it? But what we have today is that we use barrels as a common term still, and there is a standard barrel, and a barrel is about 42 gallons. You might hear tons, okay? And tons are about 7 barrels. And from a single barrel of oil for the United States market, that about half of it goes into gasoline. And about 40% goes into diesel. And then there is a residual, and that's the tar that goes on the streets that you drive in. And so those are the barrels when I refer to barrels. That's now a standard. So how much oil is there left on the planet? Best estimates from the geologists that there might be like 1.5 trillion barrels of oil left. 1.5 trillion barrels of oil. So I'll come back to that when I talk with you about use. And that is this oil that we call conventional. There is a huge amount of oil in sands and in shales, and we call these heavy oils. And there's this tremendous amount that will last many centuries, potentially. But we're interested in conventional oil for today. And so where does oil get used? And if you look around the planet, the United States is the biggest consumer of oil. The world, and I'm going to round numbers, so forgive me, that it's about 100 million barrels of oil get used on the planet every day. And the United States, and I'm rounding again, but it's like 18, and you can see 18 here. The United States uses 18 million barrels of oil a day. Okay? And that's about 20% of the world's supply. We have, let's say we're 5% of the world's population, and we're using 20% of the production. The other runner-up is China, and China has a population of over 1 billion, 1.3 billion. You could take away the population of the United States from China, and you still have 1 billion people. So it's not surprising that China would have a great use for oil. So I mentioned other uses, and so I've said gasoline, and we have heating oil, and so those are other uses for oil. But one that you may not recognize is that we use some oil as far as in plastics. And it's about 6% of the world's oil supply goes into plastics today. And 6% doesn't, it sounds like it's consequential, but here's a consideration. By 2050, that 6% is going to increase to about 20%. 1 out of every 5 barrels of oil will go into perhaps single-use plastics. And here's a consideration. Those single-use plastics, these water bottles, okay, if you gather up the water bottle consumption in the United States, just the plastics that go into the water bottles, that use is about 20 million barrels for just the United States into single-use plastics. So one day's use of oil by the United States goes into plastic bottles that we throw away. Consideration. By 2050, this 20%. I put out another side. If you're into plastics in the ocean, you should go see the exhibit over in Clark Hall that is Aboriginal art of fish made from ghost fishing nets. There are plastics that go into the ocean, and there is increasing amounts of plastics in the ocean that by 2050, the same 20%, there will be equal amounts of plastics in the ocean as there are fish. So think about single-use plastics, 10 million metric tons a year. So we've got a growing population on the planet. The population may top out around 10 billion or so by 2050. And the forecasts are really hard to come up with how, because we've been increasing efficiency, and how do we come up with how much oil will be used. And the best estimates are that oil consumption oil production and reuse is going to still increase for some while. And then somewhere in the next 30 years or so, renewables potentially will equal the amount of oil. But we have a population increasing the whole time. So it's not like oil is going to get turned off overnight. And it's going to be somewhere around 2050 that we're going to start seeing that renewables are going to actually have greater use than the fossil fuels. Just for fun, we have all these models, and I bring up this statement from a long time ago that says, like, well, ordinary people, we think about things in the present, but if we're trying to plan in the future, it's very difficult to come up with what this is. And these are some of the models. And the models that are for the use of oil look like it's going to be increasing. And so these are my actual numbers over that same period. And these were some of the models. And it's kind of interesting. We in the United States right now are producing more oil than we ever have. And that's what this is. So that's why the oil is so available now. Just for fun, I know a lot of you are Virginians, and you say, well, what about Virginia? And so this was something I grabbed. And about a century ago, you could have bought oil in the stock for Virginia for about $1 a share. And we do produce oil in Virginia. It's on the order of a few thousand barrels a year. Think about that with 23 million barrels a day. So Virginia is not one of the oil-rich states. So at what cost are we producing this oil? And the cost potentially is oil spills. These are huge, potentially. They have immediate economic, social impact. We affect fisheries. There's enormous cleanup costs. Millions of marine animals are killed, fish and marine mammals and birds. And the damage is even greater when you think about it because there are lots of chemicals that are toxic for use for cleaning up the oil. People tended not to think about oil in the marine environment until, I'd say, around 1967, when there was off of England this ship, one of the first supertankers that had over 100,000 tons of oil on board, 7 barrels per ton. And the Torrey Canyon started breaking up and had all this oil on, and nobody knew what to do with it. And they called in the Royal Air Force, and they said, I know what to do with it. We're going to bomb it and sink it. And then they set fire to it, and it caused this great cloud, and the Torrey Canyon eventually sank after this huge spill. But we didn't know what to do with it. And I would suggest that we still don't. When people really became aware of supertankers and their capacity to spill oil actually happened in 1978 in a ship off of the coast of Brittany, France. And it was called the Amico Cadiz. And it spilled 227 tons of oil off the coast. And nobody cared about it until they recognized that that was the coast of France. That was a tourist area. And people were very concerned about oil coming ashore into Brittany. Eventually, the tanker sank. Well, it was sunk. But now people were aware of the potential for oil spills. You probably know about the Exxon Valdez. Okay? Well, it's over a quarter of a century that the Exxon Valdez. And if you had that happen, if you went to Alaska today, into the area that the Exxon Valdez spilled, when only a small amount was able to be recovered, you would find that there is still oil in the sediments of the Back Bay. You could put your hand in, and the oil would still be coming up. It's a cold water environment. Oil doesn't break down. So little of the oil actually was recovered. But you know about the Exxon Valdez that happened a quarter of a century ago. The number of tanker spills like the Exxon Valdez is declining. We have greater restrictions. We have greater safety considerations than before. And I think one of the eventualities for the Exxon Valdez is that we are much more careful. We have double-hulled tankers. And so there is this decline. But if you look at the tankers and you know about the Exxon Valdez, so here's the Exxon Valdez. It's this tiny spill compared to so many of the other spills from tankers, but you know about it. And why do you know about it? CNN was there. It was happening in the United States. And so we had this event that was the result of something happening in the United States. But the ones that you know about nowadays are things like the Deepwater Horizon, which I think you should see the movie, not the advertise. It's pretty good. The Ixtoc spill, which I would guess very few of you know about, happened, and Althea mentioned it, but it happened in the Gulf of Mexico. I wrote up an article. It's in the old alumni magazine from 2010, and it's called An Almost Forgotten Oil Spill. And my last line is, we seem to have forgotten. And the last line is, maybe we wanted to. Because the responsibility for oil and the use of oil lies from the people looking for it to the end users, and that's you. You know, you are part of the reason that we have oil spills. So the Ixtoc spill happened over the course of a year, and some of it was cleaned up as a different kind of oil. Where you do hear about it, so I have, for example, an example here of Ixtoc and the size of the spill. And the Deepwater Horizon, which happened 7 years ago, which is kind of incredible that it seems like a long but short time. We still don't know the outcome. For Deepwater Horizon, it was a massive spill, perhaps twice as large as the Ixtoc spill. This was the largest accidental spill in the history of the planet. And you don't know about it. And then here, the Deepwater Horizon, you all know about because it only happened a few years ago. Probably what you don't realize is that the methods for cleaning up involved 40,000 workers. It was right off the coast of New Orleans. We were really lucky that there wasn't a hurricane coming in at the same time, because all of that would have gone into salt marshes. And we used about 2 million gallons of a material called COREXIT. You want to take a shot at how to say that? Corrects it, because it corrects it. That's how we clean up oil. It's basically soap. And we sprayed in 2 million gallons. That was about 20% the size of the Exxon Valdez spill. And we were purposely putting this in. This toxic material was being used to clean up the oil from the Deepwater Horizon. So these are accidental spills. The largest spill of all time happened during the Iraq War. And there was purposeful blowing up of wells, putting oil on the beaches. And that was perhaps twice as large as the Deepwater Horizon. That was during the Persian Gulf spill of 1991. U.S. oil production is very close to the size of that spill. This is the Deepwater Horizon, and there's the Exxon Valdez. But you know about the Exxon Valdez. A very small spill. CNN was there. So look to the future, and at what cost? Where are you going to look for the next amount of oil? The Deepwater Horizon drilled the deepest well in the history of the Earth in drilling. And it was going into unexplored territories in very deep water. And these are locations as we challenge our technologies to go and get more oil. Because we're going to be using more oil, demand is going to be there for the next 30 years. It's going to be increasing. A place where there's been a lot of description is because the oil companies keep their plays secret, okay? And I don't have access to those secret, that information. But there are published areas that the United States Geological Survey has. And those areas include the high Arctic. And the high Arctic, within the territorial limits of the United States and Canada, right here, there is perhaps 100 billion barrels of oil. A huge amount, 30% of the world's undiscovered oil and gas can lie up in that territory. And I mentioned that to you, and it's just like, well, that's great news for the United States, isn't it? Because we will have this oil supply. And I mentioned that, And this is important, actually, with what's happening in Florida, too, because you've probably heard about global warming. And in fact, similarly, in the high Arctic, and I have this is a capture of September 5th. So I tried to get it for today, but here. And what you're looking at, this is the ice cover, basically today, of the high Arctic. And what that says is a couple of things. One is that ice cover, and so here's the end of the winter. This year was the lowest amount of ice cover ever in recorded history at the end of the winter. And that was right here. Right now, we're a little bit above. The lowest amount of ice at the end of the summer, right now, was in 2012. But there's the dashed line. That's us today for the ice that's up in the high Arctic. And the other thing is, so we have low ice cover, and what we have now is passage across the pole that we never have had before. It's like there's great adventures. The Franklin expedition was to find the Northwest Passage. And so we have this opening across the Arctic. And so I asked you to reflect that this is the exclusive economic zone of the United States, and that is the average ice cover, but here is where we are today, far below. That says that this area, this is the exclusive economic zone under the law of the sea, which the United States hasn't signed ever, but we assume a 200-mile limit, and it's all open water in this area that has all this oil. There is territory in the center. Lawyers call this the donut hole, okay? That basically there is no active or jurisdiction, the ownership of that territory by any nation of the planet. There's some discussion about this. This will also mean that if you take things across the Northwest Passage, it's going to be 40% shorter. You're going to be sending tankers across the Arctic. There was, in 1969, the Manhattan carried a barrel of oil across the Arctic with icebreakers. I would say just for fun, but to prove that it could be done, there will be a spill. There will be ice, because it's not going to be constant. So transport is a consideration. We need to have some types of protection for the Arctic. And I've come back to this, and let's look at that zone right here. That's where the exclusive economic zone is, and where all this oil is. I had a really good student that was into using GIS, and we went and found the coordinates for the oil spill for the Deepwater Horizon for the Gulf of Mexico. And they said, can we move that spill off the coast of Alaska where we're drilling for oil? Shell was drilling there. And that would be the size of this spill, covering the entire exclusive economic zone of the United States. Fisheries. There are populations of whales that depend on that zone. There are 8,000 gray whales. The last population on Earth lived there. And it would cover that zone. Let's say there was a spill, like the Deepwater Horizon, or like Ixtoc that went on for a year. How do we clean it up? Well, can you use Corexit? We don't know a thing about it. We don't know anything about the effect of Corexit in oil on ice. And when we're drilling there, it could have happened. We don't know the effect of oil coming up under ice. And curiously, nobody's thought about the oil that would come up in the wintertime if the spill went on for longer than a month. Because, as you know, the Arctic is under total darkness. How do you find oil in the dark? And another sidelight is that if we're drilling here, not the 40,000 people that helped with the BP spill, but you are 1,000 miles from the nearest Coast Guard station. Things to think about. Should we be drilling in the Arctic? Should we open up the Arctic for drilling? And it is. And that's just the United States. There are other countries involved in here. There's a lot of oil drilling activity here, and there's very little preparation. And I'll summarize, finalize this with just a comment. And this is the paper from the Washington Post that was just a couple of days ago. And it is political truth. Soviet Union, Russia started out building icebreakers, and now they have this icebreaker capacity that are well over 100 really good icebreakers. The United States has 2. One is really old. The other one is the Healy that I've been out on in the Arctic Ocean. The truth is, this amount of oil that's up in the high Arctic is going to be involved with some political decisions, especially the ones that are out in that donut hole. The United States is not party to the law of the sea, and that's the law. Anyway, the path forward is going to be complicated. We are dependent on oil, and it's going to be risky. We're going into areas like the Arctic. We're going into areas like the Deepwater Horizon was drilling, and there will be accidents. We have to be prepared. Thank you.
Questions, anyone? Can you wait for the microphone? Thank you.
You talked about transport. What about pipelines?
Pipelines are clearly the alternative to transporting more oil, and we have the technology for safe transport of oil through pipelines, much safer than the pipelines that are presently in use. Okay, so pipelines for oil, you know, we are dependent on oil, and now it's a matter of where do we access it. Okay. Yes. Oh, I'm sorry. Go ahead. I forgot.
Hi, 2 questions real quick. You can answer either or both. Concerning Corexit, should there be any kind of mandates, or is this too much regulation and bad for business to mandate to drill in the Arctic, where you said there's no studies on Corexit with ice, to mandate that there's some studies with that before they actually do the drilling? And then also with the Deepwater Horizon spill, there's natural microbes in the Gulf that do eat oil. Has there been any progress or plans of being able to multiply those or use those in certain areas of oil spills to help clean it up in more of a natural biological manner?
Those are great questions. And so are you a chemist or engineer? And the answer is, first on Corexit, there are countries that forbid the use of Corexit. And there are no simple regulations for the high Arctic drilling of oil. You know, there is no, we're going to have an oil response team in the high Arctic that even include booms for isolating the oil. It does not exist. And the use of Corexit in ice is currently beginning to be tested, but we're already drilling there. Okay? So the answer to the question is yes, but. And now, as far as the Deepwater Horizon, there's a bit of controversy between whether the microbes are eating the oil. I actually had a very good interaction with a friend, a geophysicist from New Hampshire, who said, you know, he was part of this National Academy study that said the Corexit got rid of the oil and they couldn't find it. Well, they didn't look for the Corexit also, because it's soap. How do you analyze soap and water? And so I think there are microbes that can consume some of the oil. But oil is like millions of compounds. I've done studies myself in salt marshes. And if you have microbe populations up in the Arctic, or Alaska is another good, 25 years later, where are the microbes? They're watching the movies, you know. And so where, it's a difficult situation. In warm areas, sure, there's going to be microbial degradation. The asphalts from Israel are microbially degraded oils. And they're only millions of years old. So great questions. I hope I answered.
Yeah, I have 2 questions. In the Caribbean, you have natural leakage of oil from the floor. How does that compare to the Deepwater Horizon? And the second question, with all these plastics that are made from oil, do they ever, under certain conditions of temperature and pressure, as they return to oil?
Okay, those are excellent questions again. One of my favorite stories was when I was a graduate student at the University of Texas, okay, and there was a controversy about whether there were oil seeps like that creating the tar balls that you would find in the Caribbean and along the coast of Texas. Obviously there were. We did a little investigation of history, and it turns out that there were Karankawa Indians that lived along the Gulf Coast, and they used to use oil from seeps to caulk their boats. The other thing was that they were known that you didn't want to get invited home for dinner, if you get my drift, because you might be dinner. But the oil that is coming up in the Caribbean is a tarry substance, and it's biodegraded, and it's going to, it will last as a biodegraded oil. That microbes cannot, as you can see on the streets of Charlottesville, microbes don't degrade the asphalts very well. And so with Deepwater Horizon, there has been some thought that there is some degradation, but the studies are far from incomplete. A friend of mine, Mandy Joy, is thinking that the bottom of the Gulf of Mexico is covered with oil. So it's in opposition. Now, about plastics, you know, we have single-use plastics. 10 million metric tons of plastics make it into the ocean from the land environment every year. 10 million tons. Can you turn that back? It's not going to turn back into oil because we've refined it. We've made it chemically into these long chains that are really not degrading. And in fact, the real concern, and I just had a student finish up doing this as her PhD, that the plastics that we see, that people used to say, oh, it's going to last hundreds of years, it's longer than that. Because what happens is the plastics break down into smaller and smaller particles. That's salt, and that is the physical effects. What happens is those tiny particles are just the right size for feeding fish, for feeding the zooplankton. So they are just the right size. So it's upsetting the food chain. And the poster children, if you will, are the turtle with a piece of plastic wrapped around itself, or a bird. Those are small-scale phenomena. The really big stuff is where you have these microplastics that are not degrading further, but it will never return to oil. So we do have processes. We collect it, we recycle it, and so I encourage, strongly encourage recycling. Buy a water bottle, and that's, reuse the plastics minimally. Okay.
In your forecast of supply and demand, do you account for gas equivalent barrels?
Well, there is, and that's a lot of what's up in the Arctic, and in fact, gas hydrates. And so for the forecast for the use, the gas and other, like gas and coal are not accounted for that, okay? And there is hundreds of years of gas and oil. The calculation that I didn't tell you, that for oil on the 1.6 trillion barrels on our present use, is that oil will go on into the future for at least another 50 years from the conventional stocks that we know. Okay, that's not gas and coal. Okay. Yes?
You didn't mention fracking at all, and that's a big topic today, and how that affects the groundwater.
And I have great faith in engineers. Two of my kids are engineers, and fracking, the old style of fracking, where they had the pipes go down, not very well sealed, I suspect. And so fracking is a way for using some kind of shock on places where gas is in shales, and to release that gas. And so why we have this great abundance of gas right now. And so there is danger, okay? And the danger comes from not doing things right, which is exactly what happened for the Deepwater Horizon, and that's what happened for the Ixtoc spill, that the blowout preventers weren't tested. The engineering was there, but you didn't do the test. So I had my own feeling on fracking is that if it's done correctly, and it's not going to be contaminating the surface where we're getting the water from, but where the fracking is happening at deep locations, can be done safely. Okay.
One more question, Steve.
You raised some serious environmental concerns about Arctic exploration. I was thinking as I heard that, Well, 40 years ago, we were concerned we'd run out of oil. Now the word is that the world is awash in oil, and the price in the current market, hovering around $50 a barrel, isn't strong enough to support exploration in the Arctic region. And I think it was Shell that canceled plans for a major expenditure exploring in the Arctic. So could you comment on how realistic it is in the current supply and demand situation for companies to invest in exploring the Arctic region?
Okay, no, a great question. In fact, Hillary Clinton came out totally against drilling for oil in the high Arctic. The idea for drilling the high Arctic from an environmental point of view, the fact that the oil price crashed, I thought great, because it no longer was. Shell invested billions of dollars in a couple of wells that had a limited amount of oil, oil shows, they would say. And so in the present market, we're not going to have that type of activity. For the future, I would hope that we will be developing techniques, because oil spills will happen, tankers will rupture, and we have to be prepared. I'm not anti-drilling forever in the Arctic. I'm a great believer in preparedness, and preparedness includes giving funding to the chemists to clean it up, figure out ways for cleaning up, storing a response for all the nations, not just the United States, in the Arctic Ocean, and using that as a way for getting at the oil. Depending on, American engineers are the best on the planet. And we throw it into their minds, their creative minds, and say, how are we going to deal with this? And they'll come back and say, test the damn blowout preventers. All right? Anybody else?
Your graph on the frequency and size of spills didn't go back to World War II. And I vividly recall growing up in Florida, the site of burning tankers, particularly in 1942 and half of 43. Any comments on the volumes?
I don't know the statistics on how many tankers. They were small. They weren't the super tankers of today. That's one thing. And that has been pointed out previous, like the submarines were taking out ships that had oil on them. And it seems like they were small scale, and that I can't address it more than that. But it didn't go back to World War II, and clearly there were oil spills then. So, but that's a great question for future investigation. Happy to talk with you, and maybe you can give me some leads.
Steve?
Yes?
Hello. Thank you for all the information today. My question is, what could possibly be the scientific effect on the planet of pulling the oil out of our reserves of the planet itself?
Okay. So there is great discussion going on about actually tapping into these reservoirs, and there is some suggestion, and I think we're still in the early stages, that that amount of removal could affect earthquakes, for example. And so, we tap into the water reserves down in Florida, and we have the great sinkholes. And so I think there is potential. We have to be concerned about those locations, and that's going to be bringing in geologists along with the engineers and the oil companies to say, well, is this a good location? And that's something that we don't typically consider. Okay, I'm involved with a project down in Southwest Virginia that is it's a carbon sequestration project where we're pumping CO2 into old coal fields, and the idea is you can bring CO2 down from the atmosphere if you have a place to store it forever. Well, CO2 might be happy at a kilometer or two depth. It actually forms a liquid, but what are the effects of us pumping that into those old reservoirs? And it could be, potential for earthquakes. Is there? You have to do the environmental assessment of risk. All of these decisions, whether it's, filling up your car with gasoline, there's a cost benefit. And we have to weigh those carefully, those cost benefits, and I think that's where we are. And, we need to inform citizens to make that cost-benefit analysis. One more, okay. You?
Personally, following up on what you just said, personally, what do you do in your lifestyle to diminish your own impact on the environment in terms of?
That's a great question. I've had the same thing. Althea mentioned King Corn, where I was talking about human diet and the influence of corn on society. And I had the same question, what do I do? Because in King Corn, I'm eating a corn-fed beef hamburger. And, but there are simple things, okay? For diminishing my own impact, I have a hybrid, okay? Hybrids are the future. Personally, I try to cut down on my own amount of plastics that I use. Single-use plastics are really bad news. If you go to Panera Bread, don't take the plastic straws. You know, that's the simple things. I mean, you can have your own small impact. When you go to a beach, in my class, when I go to a beach, we pick up plastics on the beach and we take it home. So there are small lifestyle things that you can do. You know, whether it's going solar, I haven't made that decision yet. My engineer's son said you should go solar, and so we'll see. Anyway, so that was kind of dancing around here quick, but it's a good question. I'll get to you.
Thank you very much, Professor Macco. Thank
Thank
you
you.
so much. We appreciate it. Always a pleasure to listen to you speak.